Okay. Well, very good morning, guys. Fine. So last day we have been talking on I think we just stopped with operator overloading, right? Yeah, last day we just been stopped with operator overloading. Okay. So last class we just been stopped with the concept of operator overloading. What do you say? Ray, just like you can overload methods, we can also overload the operators. Is the voice not clear? Guys, is the voice not clear? Am I audible? Clear, huh? Okay, who is feeling not clear, just disconnect and connect once. Who is feeling not clear, just disconnect and connect. Okay, fine. So this is where we stopped in the last class here, operator overloading. Just like you can overload methods of a class, you can also overload operators of a class. What is that? Just like you can overload methods of a class, you can also overload operators of a class. Operators of a class also can be overloaded. So if you try to overload the operators of a class, what do you call it? You call it as operator overloading. I repeat, if you try to overload the operators of a class, you call it as operator overloading. Okay. So for that, just shown you like I have just shown you how to overload the plus operator so that we can use between two matrices. Minus operator, how to use it between two matrices. We've just been seen all these things in the previous session. Okay. The next topic what we have today is going to be constructor overloading, guys. The next topic is constructor overloading. Yeah. Just like methods in a class can be overloaded, okay. Yeah, watch it. Just like methods in a class can be overloaded, we can also overload constructors of a class. Constructors of a class can also be overloaded. Okay, and we call this as constructor overloading. We call this as constructor overloading. Okay, for example, watch it. Let me add a class. overload const.cs. Overload const.cs. Okay, so let me add a class. We'll call it as overload const.cs. And now we are just trying to define two fields here. In type will be, and then I'm writing a method called public void display. And in this I'm writing console.writeLine $, value of I is I and value of B is B. Okay, just trying to print the value. Just a minute. Okay. Okay. So simple two fields and one method. Now I'm writing another class here. What is the name? Overload cons. Sorry. Test overload cons. Test overload cons. Defining a main method here. And want to create the instance of the class overload cons here. I want to create the instance of the overload cons. And guys, all of you remember one thing. What is it? Did we define any constructor in the class? Did we define any constructor in the class? No. And when we don't define a constructor in the class, we have a default constructor in the class. When we don't define a constructor in the class, we have a default constructor in the class. So right now, if you just observe, the default constructor, what is going to be present, is used for creating the instance. And you people already know that default constructor will initialize the fields of a class with their default values. Default constructor will initialize the members of a class, fields of a class with the default value. So I is initialized with 0 and B is initialized with false. I is initialized with the value 0 and B is initialized with the value false. Okay. Now let me call the method c1.display. c1.display. And observe it, all of you. Now I and B value will be 0 and false. I did not show anything newly, guys. I just used the default constructor and I printed you the appropriate values. That's all. But I want to initialize I and B. I want to initialize I and B with some given set of values. I repeat, guys, I want to initialize I and B with a given set of values, not with default values. I want to give you an own value. I want to give my own value. If that is the case, what did I teach you? If that is the case, I taught you define a constructor in the class. Define a constructor in the class. And after defining a constructor in the class, okay, after defining a constructor in the class, I can just pass the values what I want from here now. Yes or not? Now they are initialized with default values or given values. with a given set of values. Now you can see I value is 10 and B value is true. Are you clearer or not? I value is 10 and B value is a true. Other values. Understood everyone? I and B are initialized with a given set of values now, not with default values. Pretty clear now? Yeah, that's what we have done. Now see, what I'm trying to explain you right now is, earlier when we don't define a constructor, there is a default constructor initialized with default values. Now we have a parameterized constructor. So once we have a parameterized constructor, there is no default constructor now, because implicit constructors will come into picture only when the explicit constructor is not there. So I define the constructor explicitly. There is no implicit constructor. So now, is it mandatory to pass values to the constructor while creating instance or not? Yes, mandatory, because the constructor is parameterized. It is mandatory to send values to the instance now. It is mandatory to send the values to the instance now. It is not like optional. It is mandatory. It is a must. We need to pass up all the values. I hope you guys are clear or not. It is a must. We need to pass on all the values. All the values should be passed. Mandatory. It is compulsory. We need to pass up all the values. Okay, now, are you clear, everyone? So it is mandatory to pass on all the appropriate values. So compulsory, we just require to pass these particular values while creating the instance. Okay, we'll do it. We'll pass it. No issues. We can just pass on all the required values to it. Now remember one thing here. What is that? If I want to, suppose I don't know the values here. I'm not going to pass them. I'll get error. Now. Why? Because constructor is parameterized and you're not passing. Understood my point here? So I have a requirement. What requirement? If I don't pass the values, it has to use the default values. Did you catch my point? If I don't pass the values, it has to use the default values. That is the requirement. But no chance now, because your constructor is parameterized, mandatory to send all the values now. To resolve this problem, what I can do now, I can write one more constructor in the class. See guys, how many constructors are there now? How many? 2 are there. There are 2 constructors. So I can create the instance by passing the values, and now initialized with the given values. And also I get a chance to create the instance without passing the values also, guys. If I don't pass the values, automatically default values will be used now. Are you getting me or not? Now we have a flexibility. What flexibility? If you know the values, pass the values. If you know the values, pass the values. And if you pass the values, what happens? If you just pass the values, instance is going to be created by using the default constructor. Instance is going to be created by using the default constructor. If you don't know the values, create the instance by calling the default constructor, and it will initialize the fields with default values. If you know the values, create the instance by calling the parameterized constructor. And once you create the instance by calling the parameterized constructor, automatically what will happen? Tell me. Automatically what will happen? It is just going to take the given values now and execute. Take the given values now and executes. I hope you are clearer or not. So 2 options before you. One option, use default constructor. Initializes the fields with default values. Use parameterized constructor. Pass on the values whatever you require. Now. So these are the 2 options that are available to you. Yeah. See now, I can create one instance without passing the values, and I can create one instance by passing the values. See now, in this case, I and B will be default values. What is that? 0, false. And here, Did you understand, guys? Yes or not? This is how you can overload the constructors. Okay, so this one initializes the fields I and B with default values. Initializes the fields I and B with given set of values. Understand or not? Initializes the fields I and B with given set of values. You have two options before you. One is initializing I and B with the default values, and one is initializing I and B with given set of values. Okay, now, guys, how many constructors did you find out? Two constructors. Overloaded or not? I can do like this also. Watch it. I know I value, but I don't know B value. I know I value, but I don't know B value. But here, see, when you pass, you need to pass both the two values now. Yes or not? But unfortunately, what is the problem? I know I value, but I don't know B value. Same way, I know B value, but I don't know I value. If that is the case, you can even write multiple constructors like this. Int I. This dot I is equals to I. Initializes B with default value. Initializes B with the default value now. Are you clearer or not? Same way, you can see public load cons B. This dot B is equals to B. Initializes I with default value. I hope you guys are clear or not. So like this, it is going to initialize I with default value, and it is going to initialize B with default value. Okay, now guys, see, I am creating a new instance passing only I value. Passing only I value. I am creating one more instance passing only B value. You can see, guys, first case, I and B are initialized with the default values. Second case, I with given value, B with default value. Third case, I with default value, B with given value. Fourth case, both I and B with given values. Both I and B with given values. Did you understand me or not? Yes or not? Like this, it is going to initialize you both I and B with a given set of values like this. Like this, we can overload the constructors. Understood the concept of constructor overloading now? Read this, guys. All of you, read this. Just like methods in a class can be overloaded, constructors in a class also can be overloaded. And it is called as constructor overloading. Okay? It's an approach of defining multiple constructors in a class. And if constructors of a class are overloaded, the instance of a class can be created by using any available constructor. So what is it telling? You overload constructors. You can create the instance by calling any available constructor. How many constructors are there in our code now? 4 constructors. I can call it by using any constructor. It is not mandatory to call any particular constructor for instance creation. See here, I created instance by calling first constructor. I created instance by calling second or third. Anything you can use here, that's your choice. It is not mandatory you should create instance by calling this constructor only. Is it clear, everyone? And now see, guys. Concentrate on this. Read it. This is what I explained to you. Read it carefully. First option, default constructor. Initializes all the fields with default values. Second option, parameterized constructor to initialize all the fields of the class. To initialize. Third one, a parameterized constructor to initialize some fields so that other are initialized with default values. Are you clearer or not? Basically, did you understand the concept? I want to initialize the fields in a mix and match combination. Guys, understand me, what I'm telling you. I want to initialize the fields in a mix and match combination. What is mix and match combination? Only I, only B, I and B, none of the above. Do you catch my point or not? Now tell me, how many fields are in our class now? 2. How many constructors did they define to initialize them in a mix and match combination? 4 constructors. Tomorrow, if you have 3 fields, guess, if you have 3 fields, how many constructors should be defined to initialize them in a mix and match combination? Louder. 9. Wrong answer. You know permutations and combinations now? In mathematics, you learn permutation and combination. A, B, C are the fields. I want to initialize them in a mix and match combination. Means only A, only B, only C. Okay now? Next. AB, AC, ABC, sorry, BC. Next, ABC. Next, none of the above. I don't want anything at all. How many? 9 or 8? 8. Now, if you have 4 fields, you tell me now. Two fields, 4 constructors. 3 fields, 8 constructors. If there are 4 fields, how many constructors should I define to initialize them in a mix and match combination? Calculate here, calculate permutations and combinations. Did you understand the question? 16 constructors, Prabha, right? 16. 5 fields. Watching on the screen, I did not find you doing any calculation. You know mathematics, forget mathematics. Then do the calculation here. There are 5 fields. How many constructors should I define to initialize them in a mix and match combination? 100 is wrong. For 4 fields, 16 and 5 fields, it became 100. Wrong. Wrong. 16. It is 16. It is going to be 16 constructor. And the formula is 2 power n, where n is the number of fields. 2 power n, where n is the number of fields. Now 2 fields now. 2 2's, 2 square, 4. 3 fields are there. 2 cube, 8. 4 fields are there. 2 power 4, 16. 5 fields are there. 2 power 5. 32. Are you guys clear? I given the note there below, see. Raju, obj.I is equals to 10. Try to initialize them like that from your test overload cons. Raju, try to initialize them from your test overload cons. Try. Your class is overload cons. Go to test overload cons and try to initialize them. And then come back and ask this question. Okay? Are you clear with the note all of you? Yes or not? So it's very lengthy process. Now, tomorrow 6 fields are there. 64 constructors I should define. Remember all of you this particular point. How to simplify this, I'll teach you in the later classes. How to simplify this work, I will teach you in the later classes. But as of now, the formula is 2 power n, where n is the number of fields. Is constructor overloading clear, all of you? Tell me. Okay now? Fine. Next. The next thing what we have going to discuss is about copy constructor here. Copy constructor. What is the next one? Copy constructor. What is copy constructor? Watch. I'm defining a class here. We'll name the class as copycon demo. In this class, I have 3 fields. Simple. 3 fields. And I want to define a constructor and initialize the fields. I want to define a constructor and initialize the fields. Suppose, guys, I want to do it like this. I explained you in the ATM system case study, remember? What is that? When I want to initialize, when I just want to initialize, guys, when I want to initialize, I said you will do ATM here. When you pass the customer ID, the rest of the values gets loaded from the database. Remember or not? So no need to pass all the parameters, only one parameter. What is parameter? ID. The rest of the other values should come from database. So how do you write? Public copycon demo. We pass customer ID as a parameter. Then we say this dot customer ID is equals to customer ID. Rest of the values should load from where? From the database. For the time being, I'm writing name is equals to Raju and balance is equals to 5,000. Are you getting me or not? Name is equals to Raju and balance is equals to 5,000. Are you guys clear? So like this, I'm just going to initialize the fields of my particular class. I'm going to initialize the fields of the class. So done. They're initialized. Okay. They're just initialized now. You can just see all the fields are initialized now in this way. Now, if you look at this, all of you, just a second, guys. If you look at this, I defined a parameterized constructor and trying to initialize the fields. Static void main, create the instance. Copycon demo, cd1 is equals to new copycon demo. Copycon demo cd1 is equals to new copycon demo. And now I'm passing 1005 as a parameter. Now immediately all the three fields are initialized or not? Array, we are given static values, but what did I say? All these values should load from database. Okay, now we have given static values here, but all these values should load from where? From the database. All these values should be loaded from the database actually. From the database, we need to load up these particular values. Okay. Now you guys, I want to write a method, public void display. Same again, display method. The display method is going to display all the things now. Okay. Console.writeLine dollar. What is the first one? Customer ID. Next, name. Balance. Balance. Then customer ID, name and balance. Okay. So now I can call the method cd1.display. I did not write anything newly, guys. Same old story. Regularly, what code we are writing today also I written the same thing only. Copycon demo. Are you clear? Now, look. Oh, sorry, guys. We created one instance. Here. And that particular instance is going to load some data. And right now, the instance is initialized. Now, I want to create another instance. With the same values. I want to create another instance with the same values. So if you want to create another instance with the same values, what do? You're just going to copycon demo cd2 is equals to, and now it will, okay, we did not still write, but in the future we'll write database coding here now. Come on, yaar. In the future we'll write database coding here. We did not write now. So in the future what will happen? It will connect to database. Okay, it will connect to database. And we'll be starting loading all the data from the database now. So it will connect to the database once here. It will connect to the database once here. 2 times it will connect. Same data loaded. Are you clear? Actually, we are provided with a concept called as copy constructor. What is the copy constructor? When you want to create one more instance with the same values. Without again creating an instance like this, connecting to database, loading all the data, we can directly copy the values from cd1 only now. Did you understand me or not? Suppose the database is somewhere in a remote location. Yeah, it is taking a lot of time to connect to the database now. First instance connected, loaded the data. Second instance again required to connect and load the data. Maybe time taking. To speed up the things, when you want with the same 1005 only now, when you want the same, without connecting to the database, you can load the values from cd1 directly here now. Yes or not? So that is the basic idea of a copy constructor. Copy constructor is a mechanism of creating a new instance by copying the values from an existing instance. Did you understand me or not? Copy constructor is a mechanism which is used for copying the value, is a mechanism of creating a new instance by copying the values from, means you are going to copy the values from one existing instance to another instance now. You are going to copy the values from one existing instance to another instance now. One instance to another instance, you are just going to copy the values now. Are you clearer or not? Understood my point? From one instance to another instance, we are copying the values. We just copy the values from one instance to another instance. So that is what we call as a copy constructor. But how, sir, how to do that? If you want to do that, that constructor should be defined in your class first. That constructor should be defined in the class first. How? Watch. Guys, now I'm defining the copy constructor. This is a new concept. Listen carefully. This is a new concept. Public copycon demo. Public copycon demo. And for this copycon demo, what am I passing, What am I passing, Guys, watch it. I am going to pass copycon demo only as a parameter. Means, see here, what is the type? Int is a type. But here, what is the type? Copycon demo. Array, copycon demo is a class, and every class is a type now. Okay? Now see, when you defined another new constructor here, how many constructors are there now? 2. One constructor taking int as a parameter, and one constructor taking copycon demo as a parameter. Okay, here you created instance by calling int constructor, correct? Now here, I can just pass cd1. What is cd1? cd1 is nothing but a value of type copycon demo now. Are you clearer or not? So second constructor takes copycon demo only. I'm passing cd1. Now tell me, cd1 contains all the values in it? Array, first cd1 contains all the values in it. The values will be passed to cd. The values will be passed to cd. The values will be passed to cd. Now, can I write here code like this? This dot name is equals to cd dot name. This dot customer ID is equals to cd dot customer ID. This dot balance is equals to cd dot balance. cd dot balance. And guys, did you understand? You are copying the values from one instance to another instance now? Yes or not? Okay, we are copying the values from one instance to another instance now. And you see now, cd2 also contains the same values. Are you clear? And be careful here. What happened? First you created an instance. This connected to database. Loaded all the data. I want to create another instance with the same values. Again, don't go to database and all. You can copy the values from the existing instance to a new instance. And don't forget, this is not a reference, this is an instance. This is not a reference, this is an instance. Means, why I'm telling you is, you have a doubt here. Sir, we can do like this also now. We can do like this also. But remember, in this case, CD2 is not an instance. CD2 is a reference. Changes of CD1 will reflect to CD2 and changes of CD2 will reflect to CD1. We'll learn to report that now. But guys, this is not a reference, all of you. This is a new instance. This is a louder new instance. This is completely going to be a new instance in this particular case now. So two instances, two separate memory allocations. Two instances with two separate memory allocations. For example, look. Okay, initially both of them have the same values only now. Initially both of them have the same values. Voice is disturbing now. Check now. Check now, all of you. Check it now. What now? Still disturbance of the voice? Hello? Hello? Just to check out now. Is it fine? Clear now? Okay. Yeah, okay. Okay, guys, now watch. Here, understand, this is a new instance and this is a new instance. These are two separate instances. So CD1 will have its own memory, CD2 will have its own memory. Okay, watch. Guys, observe it. If you watch, right now both of them are going to have the same values. Same values are there. Console dot write line. I'm giving a line break. I'm giving a line break. After giving a line break, okay, I'm just going to say CD1 dot balance. CD1 dot balance is equals to 6,000. And you guys observe, because these are two separate instances, changes of CD1 will not reflect to CD2. But if there is a reference, changes of the instance reflects to reference or not. See now, this is 6,000, that is 5,000 now. The changes of the CD1 did not reflect to CD2. Okay? Again, one more time. Observe. I am saying CD2 is equals to 7,000. And that change won't reflect to CD1 now. Are you clearer? These are instances or references? Instances, not references. Okay, this is completely different from creating a reference. This is a new instance. This is a new instance. But someone will have a doubt here. What is the doubt? Why do you want to create another instance with the same values? Why do we want to create another instance with the same values? Generally, guys, we use these things in case of arrays. We use these type of things in case of arrays. When you're working with arrays and all, we use it. What is that? I have an integer array with some 50 values in it. Carefully listen. I have an integer array with 50 values in it. How many? 50. Are you clear or not? There are 50 values in an array. And when you're going to have some 50 values in an array, when you're just going to have some 50 values in an array, at that particular point of time, how many values are there? 50. Okay. And now, you want to do some manipulations on this, like sort. You want to sort them. When you want to sort them, what will happen? It won't create a duplicate copy. All the values in the array will be sorted. All the values in the array will be sorted. Again, if you want to get back the original copy, you can get it. After calling sort, no, get back to the original state, I can't get it again now. Did you catch my point or not? I call sort here, I have an array with 50 values, integer array with 50 values. I sorted. After sorting, I felt that, no, again I should bring it back to original. How the original values are there, I want to bring it back to original values. I can get back again. Why? Once sorted, the values are rearranged. So that's why in this type of scenarios, what we generally do, you're sorting or reversing or you're doing any manipulations, we try to maintain the original copy as it is like this. If you want to maintain the original copy, what you require to do? You require to create one more array and copy all the values from the first array to a second array now. Array, without that, directly use a copy constructor. So we'll create a new array with all the values present in the old one. Now do the manipulations in the new array. Old one will be like that only. You can do all the manipulations in the new array now. Are you clearer or not? Understood? Okay. Generally, when you are working with arrays, collections and all, these copy constructors are basically used for copying the values from one instance to 2 or 3 values present, we don't understand here, but simply some 100 values are there. You need to copy all the 100 values from one to other. It takes a lot of time to do that. So in that cases, copy constructors will help you in creating a new copy with the existing copy. New copies are created. Someone asked you this question, what is the use of copy constructors? Understood? Again, I'm breaking up. Now, is the one breaking still? How is it now? Now, how about the voice now, guys? Is voice clear now? Let me disconnect and connect. Let me disconnect and connect. I'm disconnecting and connecting all of you.
Recording stopped. Recording in progress.
Hello. Hello. Please check out now. Am I audible? Okay. So did you understand? Did you guys understand what is the use of a copy constructor? Did you guys understand what is the use of a copy constructor? Tomorrow, when you're working with arrays, and you want to manipulate them, before doing all the manipulation, I want to maintain the original copy of it now. Before doing the manipulations, I want to maintain a original copy of that. So to maintain the original copy, what do? We use a copy constructor. So what will happen? All the values of one array will be copied to another array. There can be 100 values, 200 values. All the values will be copied from one array to another array now. Okay. Some 100, 200 values are there. All these values will be copied from one array to another array. So that is the real advantage, or that is the real use of a copy constructor in our applications. I hope it's clear, all of you. Okay. And now guys, listen. When we are talking about constructors here, constructors are divided into 5 types. Constructors are divided into 5 categories. They're divided into 5 categories. What are the 5? You know them now? You know default constructors, I don't require to explain you. Second one, you know parameterized constructors, I don't require to explain you. Just now I explained you copy constructors. Fourth one, you learned about static constructors also. Static constructor is the first block of code which executes in your class. Last one, nothing here. If a constructor is prefixed with a private keyword, if a constructor is used with a private modifier, that's a private constructor. And remember, I explained about these private constructors in inheritance for you. If a class constructor is not accessible to the child class, inheritance is not possible. First in the parent class, we defined a private constructor. Then child class was not able to access it. In the parent, we defined a private constructor and the child class was not able to access it, right? Private constructor. So totally tomorrow in interview, if you are asked about the types of constructors, you are required to say 5 types of constructors. What are the 5? Default, parameterized, copy, static, private constructor. Totally 5 different types of constructors are what we just have in our object-oriented programming. All of you please once read it. Come on, read it guys. First read about default constructor. Understood? Default is clear? Right. We define default constructor, nothing special to explain. Parameterized. Third, copy constructor. Just now explained you. Read it. When we learned about reference, we learned, remember, changes of the instance reflects to reference, changes of the reference reflects to instance. But here very clearly, the changes won't reflect to each other. Guys, are you done with the first three? Are you guys clear? Default, parameterized, copy. Default, parameterized, copy. Next. Static and private. Rate them also. Okay, now basically we use this private constructors for creating singleton classes. We use this private constructors for creating singleton classes. And now you'll be wondering, what is singleton class? We will talk about the singleton classes when I explain you MVC, guys. In MVC, I'll teach you what singleton classes. Basically, in simple words, singleton class means for this class, you can create only one instance. Generally, for a class, we can create multiple instances now. But for these classes, we can create only one instance. Multiple instances cannot be created. So we call that as a singleton class. What is the use of it? I'll talk about this when I explain you MVC. In the MVC classes, I'll teach you about this. Okay? So ignore it for the time being. But constructors are 5 types. And are you clear with all the 5? You defined all the things here. You defined all things and you tested them. Okay, now. Okay, next. The next topic is sealed class. Guys, listen. Sealed class. What is sealed class? If a class is explicitly declared by using sealed modifier. If a class is explicitly declared by using sealed modifier, we call that class as a sealed class. We call that class as a sealed class. Nothing here. When you define a class, we are going to use a sealed modifier on the class now. And you call the class as a sealed class now. For example, class 1. Okay. Now here I am writing understood all of you? They will be asking, so what is the use of it, sir? What is the use of it? Remember, if a class is declared as sealed, if a class is declared as sealed, we cannot create Are you clearer or not? I'm sorry. We cannot inherit. I'm sorry guys. We cannot inherit from that class. We cannot inherit from that class. What do you mean? What I mean is, inheritance not possible here. You define a class there called class 1. Now I'm writing class 2 colon class 1. Invalid now. Why? Because the class is declared as sealed. So if a class is declared as sealed, we cannot inherit from that sealed class. Are you clearer or not? That is, if we want to consume the class, it can be done only by creating instance of that class, but not by remember, a class can be reused in 2 ways. One is inheritance. Second one, instance creation. Till now, every class supports inheritance and every class supports instance creation also. Our choice. We can create an instance and use it, or we can inherit and also use it. No problem. Are you getting me or not? We can create an instance and use it, or we can inherit and also use it. But if the class is declared sealed, we cannot inherit. What we can do? We can only create an instance and consume. An example, sir? Yes. What is that? String. So, it is never possible to, but we can consume it. String is a sealed class here. String is a sealed class. We cannot inherit from this class, but wherever you want to consume, you can consume. How to consume? By creating an instance. You can verify. Already I shown you this option. Do you remember? Right click on a class and choose the option go to definition. I already said you this option here. If you go to the definition and watch, see guys, string is a class. Sealed class. Public sealed class. It's a public sealed class. So string class can be consumed anywhere you want because it is public. But only by creating the instance, but not by inheriting. Inheriting will not be possible. I hope you guys are clear. Come on, respond. Is a sealed class clear? Same way, we have sealed methods also. We have sealed method also. Just like a sealed class, we have What is sealed method? What is sealed method? Listen. If a parent class method cannot be overridden under the child class, then we call it as are you clearer or not? If a parent class method cannot be overridden under the child class, then we call it as sealed method. You can't override the method, guys. Okay? And don't forget one point. By default, every method is a sealed method. By default, every method is a sealed method. Is it? Yes. Because we can never override any method without Ray, don't forget here, you cannot override a method without declaring the method as virtual, correct or not? When can you override a method? If you want to override the method, the method should be declared as virtual. Are you clear? What's your question? Means virtual is also not possible under sealed method. And if you don't write virtual only, that is sealed. Ratna Kumari, if you don't write virtual, then it is sealed. If you write virtual means it is not sealed. You are opening the seal now. By default, every method is sealed method, guys. By default, every method is sealed method. I am opening the seal now by declaring virtual. Don't forget it. Okay, look at this carefully. I have class 1. Here I have a method public void show. Public void show. Okay. Now I have class 2 colon class 1. Can I override the show method here? Come on. Can I override the show method here? No, you can't override. Why you can't override? That's not declared virtual. I cannot override. So now you understand show is a sealed method now. This is a sealed method. I don't recommend to again use a sealed keyword. By default, every method is sealed. By default, every method is a sealed method. Got the point or not? Okay, look again. Again, class 1, public. Now tell me, this is a, the opposite for virtual is sealed. The opposite for virtual is sealed method. Now tell me guys, can I override this method or not? I have class 2 inheriting from class 1. I have class 2 inheriting from class 1. Now in class 1, what I'm doing, say public override void show. What I'm doing? I'm overriding. Valid? Yeah, valid. Okay. Now answer this question. I'm writing class 3 inheriting from class 2. I'm writing class 3 inheriting from class 2. Can I override the method again? Can I override? I'm asking you this question. I wanted to override the method for one more time. I want to override the method for one more time. Can I do this? Yes, I can do this. This is also valid. Once the method is declared as virtual in a parent, any child class of it, I repeat, any child class of it in a linear hierarchy has a right to override that method. Any child class of it in a linear hierarchy has a right to override the method. Class 2 overridden. Again, class 3 is overriding. Suppose you define class 4 under class 3. Class 4 can again override. So how many classes can override like this? Any number of classes can override the method. Understood or not? Understand each and every scenario carefully. First scenario. What is the first scenario? Public void show. That is a sealed method. That is a sealed method. Cannot be overridden. Cannot be overridden. So coming here, and if I try to say public override void show, this is That is invalid. That is completely invalid. Okay now? But see, here we are in a public virtual void show. This is a non-virtual. And now I can override. Again I can override. Again you want to define class 4, inheriting from class 3. Can I override? Yes. Okay now. Once declared as virtual, any child class in the linear hierarchy has a right to override that particular method. No limitations or no restrictions. Okay. I'll show you one more scenario. Watch. One more scenario. Yeah. Now again, watch it. Class 3 can override the method again now? Array, class 3 can override the method again now? Just now I explained you. But I don't want class 3 to override that method. Listen carefully. I don't want class 3 to override that method. Is it clearer or not? If you don't want class 3 to override this method, if you want to make this invalid, here you're required to use sealed. Now if you use sealed here, this is, you can do. Overriding cannot be done, guys. It's invalid. Are you clearer or not? This is completely invalid operation. So what I'm trying to tell you, in the topmost class, every method is sealed method. Array, in the topmost level, every method is, but that class is opening the seal. That class is opening the seal by declaring virtual. So immediately all the children will get the right to override now. So now any child class wants to restrict the further overriding. Say, I want my child class not to override the method. I want my child class not to override the method. What I can do? So further overriding is not possible. What is not possible? Further overriding is not possible. Means overriding is limited for there only. Are you clear, guys, clearer? Understood or not? So this is about sealed class and sealed methods. Okay, just a minute. All of you read this once. Come on, start. First, sealed class. No, you can't do anything on hiding. And hiding doesn't take parent method into consideration at all. Hiding doesn't take parent. It's about overriding. That's all, not about hiding. Is a sealed class clear? If a class is explicitly declared by using sealed modifier, we call it as a sealed class. And these classes cannot be inherited by other classes. For example, public class, sealed class, and you define the members. In the above case, class 1 is sealed class, so it cannot be inherited by any other class. For example, okay, now that is completely invalid operation. That's completely invalid operation. Next, read that carefully, all of you. I hope you guys are clear. Yes or not? Okay. So basically, every method is by default. Not this. If string class is by default sealed, so that cannot be inherited anywhere. Consuming it is possible. Wherever you want, you can consume. Can I use virtual again for class 3? I did not understand what you mean to say. You can write a new method. You can write a new method, not same name and signature. You can write a new method, but not same name and signature. Now read sealed method. Now read sealed method. Is that clear? Okay. Next. Continue it. You can call. I said your method cannot be overridden. That's all. I did not say you cannot call it anywhere. You can call wherever you want. Calling is possible. See, one thing you understand. Here, class 2 is overriding and again class 2 is overriding, right? Class 2 did not override. Class 2 did not override. Then also class 3 can override. Class 2 did not override. Then also class 3 can override. Point clear, everyone? Read this. Okay, now. So what is it? Class 2 has sealed it. So class 3 cannot override it. Clearer or not? So are you guys clear with the sealed classes and sealed methods? Sealed classes, sealed methods. So today what did you learn? Constructor overloading, copy constructor, types of constructors, sealed classes, sealed methods. Sealed classes and sealed methods. Okay, we have another concept called abstract classes and abstract methods, guys. Okay, I'll explain in next class. Abstract classes, abstract methods. We'll talk in the tomorrow session. Let's stop here. We'll meet tomorrow.
Recording stopped.